In our lesson today, we're going to learn how to calculate actual distances from a scale ratio. When you're working with a scale drawing, like a blueprint or a map, some sort of a scale is given so that you would be able to figure out the actual length or the actual distance of something. Okay, and so that's what we're going to practice here today. So in our first example, it's about a blueprint. Blueprints are used in construction. They want us to find the actual length of a room if the length on a blueprint is 5.5 inches. They tell us that the scale of the blueprint is the following. Okay, right here, this is the scale ratio, and they tell us that on the blueprint, a half an inch is equal to 2 feet of actual distance. Okay, so a half inch on the blueprint is 2 feet in real life. And to help us come up with the actual length of the room, we're going to create a ratio table, which you can see that we've got here. The first thing that you need to do with your ratio table is put in the units from the scale ratio. Okay, in the scale ratio, they're working with inches and feet. So I'm going to record that information in the table, inches and feet. And the first set of numbers that we're going to record in here are the units or the measurements from the scale ratio. They tell us that a half an inch, so 5/10 of an inch, is equal to 2 feet in actual distance. Okay, we're going to try to figure out what the length is going to be in real life. Now, they tell you right here on the blueprint, the length on the blueprint is 5.5 inches. So I'm going to record that right here in my table, 5.5 inches, and I'm going to see if I can figure out how many feet that corresponds to in real life. What I need to do is figure out how they scaled from a half inch to 5.5 inches. And whatever they did there is what I'm going to do to my number of feet. All right, I'm going to go from 2 feet to something. All right, but I've got to figure out what that scale factor is. Well, to go from 5/10 of an inch to 5.5 inches, all right, in order to figure out that scale factor, I'm going to set up a division problem. I'm going to do 5.5 divided by 5/10. And if I were to punch this into my calculator, all right, this is going to be equal to 11/1. So what they did in order to go from a half inch to 5.5 inches was multiply by 11. And so that's the same thing that we're going to do down here to the number of feet. I'm going to do 2 feet times 11, which gives me 22 feet. And so I know that the actual length of the room is 22 feet. Okay, so again, I started with the scale ratio that said a half inch corresponds to 2 feet. And then I figured out the scale factor by doing the division. 5.5 divided by 5/10 is 11/1. So they multiplied by 11 to go from a half to 5.5. So I do the same thing down here. 5.5 inches on the blueprint corresponds to an actual length of 22 feet. In example number 2, we're going to find the actual width this time of the room if the distance on the blueprint is 3 inches. And notice here we're using the same scale that we used in the first example. So once again with my ratio table, I'm going to put inches and feet. Those are the labels, those are the units that they're using in the scale ratio. And they said right here that a half inch corresponds to 2 feet in actual distance. And they told us right here that the width on the blueprint is 3 inches. So I'm going to put 3 inches right there. And once again, I have to figure out how they scale from a half inch to 3 inches. So in order to figure that out, I'm going to do 3 divided by a half. And when I do that this time, that's going to give me a value of 6. So 6/1. So what they did to go from a half inch to 3 is multiplied by 6. Since they did that to the inches, I'm going to do the same thing to the number of feet. 2 times 6 gives me a value of 12. And so now I can say that the actual width of the room is 12 feet. Okay, so again, whatever that scale factor is that you use for the inches, it's the same scale factor for the feet. 3 inches on the blueprint corresponds to 12 feet in actual width. For the next set of problems, we're going to be using a map of the United States, and that map looks like this. Okay, so there's a few things that we need to do before we can actually figure out some actual distances on the map here. So what we have is our map of the United States, and what we're going to be doing is finding the shortest distance between two places, and the shortest distance between two places is in a straight line. Okay, a straight line is the shortest distance between any two places. So what we're going to be doing is finding straight line distances between a couple of cities on our map. Now in part B, before we can figure out what those distances are, we need to know what the scale of the map is. And so what I did, if I take a look at my map here, okay, down here, there's where my scale is. And I'll see if I can blow this up, make it a little bit bigger for us to read. Okay, so down here, all right, the units that they have are centimeters and miles. I know it might be a little tough to read, okay, but what we're working with here are centimeters and miles. And what I had to do was figure out what the distance was from this end to this end of the scale on there in centimeters. And whatever that length is, that corresponded to, that says 300 miles right there. So when I went and I measured this, I came up with a scale ratio of 2.5 centimeters equals 300 miles. Okay, when I measured that line with my ruler, I came out with 2.5 centimeters, and it said on the scale that that was a distance of 300 miles. So what I'm going to do, I'm going to set up my ratio table, and I am going to put centimeters on top and miles on the bottom. And the first thing that I'm going to do is record the numbers from the scale ratio. 2.5 centimeters corresponds to 300 miles of actual distance. And now what I'm going to do is estimate the actual straight line distance from Albany, New York to Columbus, Ohio. So what I'm going to have to do is use my ruler and my map, and I'm going to have to find those two cities. Well, I know Albany, that's really easy. Albany's right there, and Columbus, Ohio is right here. And so what I'm going to do is use my ruler, and I'm going to measure what this straight line distance is from Albany to Columbus. Okay, and so when I go ahead and I do that, I measured a distance of 4 4.2 centimeters. So since the distance was 4.2 centimeters, I would have to figure out how to scale from 2.5 centimeters to 4.2 centimeters. And that's actually a tough way to scale. So what I'm going to do instead, I'm going to first figure out how many centimeters, or excuse me, how many miles 1 centimeter is going to be equal to. And then I'm going to scale ahead to the 4.2 centimeters that I measured on the map for the distance from Albany to Columbus. So I'm going to take my 2.5 centimeters, and the way that I'm going to scale back to 1 centimeter is by dividing by 2.5. 2.5 divided by 2.5 is 1. I then have to do the same thing to my 300 miles. I'm going to scale back by dividing by 2 5/10. And if you punch that into your calculator, you're going to find out that 1 centimeter is going to be equal to 120 miles in actual distance. Now I'm going to be able to easily scale from 1 centimeter to 4.2 centimeters by multiplying by 4.2. And if I do that to my centimeters, I need to do the same thing down here to my number of miles. I'm going to go from 120 miles, and I'm going to multiply by 4.2. And when I punch that into my calculator, I get an answer of 504. Okay, so now I know that the straight line distance, from Albany, New York to Columbus, Ohio is about 504 miles. Okay, so once again, we started out with the scale ratio that said 2.5 centimeters on the map corresponds to 300 miles in actual distance. We scaled back to figure out how many miles 1 centimeter would be equal to. And then from 1 centimeter, we scaled ahead to the distance that we measured. We measured it was 4 2/10 centimeters between the two cities on the map. So then we multiplied 120 by 4 2/10, and that gave us that distance of about 504 miles. In the next example, we're going to estimate the actual straight line distance from Albany, New York to Pierre, South Dakota in miles. And it's the same map, so I'm going to be using the same scale that I had before. And that scale was measuring in centimeters to miles. And it said that 2.5 centimeters on the map was the same as 300 miles in actual distance. Now remember, it's going to be tough to scale from this 2.5 to whatever this measurement is on the map. So we scaled back to figure out how many miles 1 centimeter was equal to. And we did that by dividing by 2.5. 2.5 divided by 2.5 is 1. 300 divided by 2.5 gave us 120. So we're actually going to be scaling from this measurement right here to figure out that actual straight line distance. So let's go to our map. And again, we know Albany is right there. And Pierre, South Dakota is found right here. And once again, we're looking for the straight line distance. Now, this isn't the driving distance because as you can see by this straight line, we would be driving through a few of the Great Lakes and that wouldn't be good. Okay, so this straight line distance is not the driving distance, but it is the shortest distance between the two cities. So I'm going to use my ruler. I'm going to measure what this line is. And when I measure this, I get a measurement of about 10 9/10 centimeters. So let me go and record that in my table, all right? The distance between Albany and Pierre on my map was 10 9/10 centimeters. I have to figure out how many miles that is in actual distance. Well, it's very easy to scale from 1 centimeter to 10 9/10. You simply multiply by 10 9/10. And so we'll do the same thing down here to our 120 miles. We're going to multiply by 10 9/10. And if you were to punch that into your calculator, 120 times 10 9/10, you would get 1,308. And so we can say the straight line distance, and this time it was from Albany, New York to Pierre, South Dakota is about, because it's not approximate, it's about 1,308 miles between the two cities in a straight line. In the next example, they tell us that the straight line distance from Phoenix, Arizona to Oklahoma City, Oklahoma is about 816 miles. I want to know how far apart are these two cities on the map. All right, so we're not going to be using our ruler here. We're going to calculate the distance on the map. All right, and again, it's the same scale that we've had before. So we have centimeters and miles. And we knew that 2.5 centimeters corresponds to 300 miles of actual distance. And once again, we wanted to make this easy to scale, so we scaled back to 1 centimeter by dividing by 2.5. And we'll do the same thing here, divide by 2.5. And that gave us 120 miles for every centimeter on the map. Now, we know that the distance between Oklahoma City and Phoenix is about 816 miles. So I'm going to record that right here. And so I have to figure out how I scale from 120 to 816. And in order to figure that out, I'm going to do 816 divided by 120. And so if I punch that into my calculator, I get 6 8/10. So to go from 120 to 816, I must have multiplied by 6 8/10, which means I have to do the same thing up here to my centimeters. And once again, this is going to be an easy process. 1 times 6 8/10 is 6 8/10. So I can say on the map, Phoenix, Arizona, and Oklahoma City, Oklahoma, are about 6 8/10 centimeters apart. In example F, Albany, New York and Madison, Wisconsin are about 775 miles apart. How far apart are these cities on the map? So the same process that we just did with our previous two cities, we have centimeters and miles in our scale ratio. And they tell us again that 2.5 centimeters corresponds to 300 miles. We scaled back to 1 centimeter by dividing by 2.5. 300 divided by 2.5 gave us 120 miles. So 1 centimeter corresponds to 120 miles. Albany and Madison are 775 miles apart. So I'm going to put my 775 right there. All right. And I have to figure out how to go from 120 miles to 775 miles. And I'm going to do that by doing 775 divided by 120. Now, when you punch this into your calculator, you're going to get 6 and 4,583, but the 3 repeats. So I'm going to put a bar over that 3. Okay, and now what I'm going to do with this, I'm going to round this to the nearest tenth. Okay, so right now it looks like 6 4/10. I look at the hundredths place, I see a 5 there. That is enough to round us up to about 6 5/10. Okay, so that's what I'm going to put here. All right, I'm multiplying by about, well, I'm going to put what I actually multiplied by, 6 4 5 8 3 repeated, which is what I'm going to do here, multiply by 6.4583 repeated. And that again is that 6 4 5 8 3 repeated. But again, we're going to say it's about 6 5/10. So on the map, Albany, New York, and Madison, Wisconsin are about 6.5 centimeters apart. So that is your scale distance on the map. In example number 4, we're told that your math classroom dimensions are 30 feet by 24 feet. What are the dimensions of the classroom on a drawing if the scale says 1 foot equals 1/2 centimeter? Okay, we need to come up with the dimensions for the length and the width. We see right here in actual distances, it's 30 feet by 24 feet. All right, so let's set up 2 different ratio tables. This time we have centimeters and feet when we look at our scale ratio, centimeters and feet. Okay, so we know that 1/2 centimeter corresponds to 1 foot in actual distance. And the first dimension that they gave us right here was 30 feet. So 30, I'm going to put down here in my feet. And to go from 1 foot to 30 feet, all you had to do is multiply by 30. So if you do the same thing up here, 1/2 times 30, well, that's going to give you a value of 15 centimeters. Okay, so the 30-foot segment corresponds to a length of 15 centimeters on our drawing. All right, but we also have to do the same thing for this 24-foot segment. So once again, I'll make another ratio table, centimeters and feet. And again, they told us 1/2 centimeter corresponds to 1 foot. And the actual distance this time is 24 feet. To go from 1 foot to 24 feet, you had to multiply by 24. So we'll do the same thing to our centimeters. 1/2 times 24. Well, that equals 12. So 24 feet in actual distance corresponds to 12 centimeters on the drawing. And so now I know the dimensions on the drawing. The classroom is 15 centimeters by 12 centimeters on the drawing. Okay, so once again, we're using this scale ratio here to help us figure out what our distances are.